So I love the movie Burn After Reading. It's a Coen Brothers movie from back in the early
Yeah.
2000s. It's funny as hell. Like, a bunch of CIA people tripping over each other. There's disaster after disaster. A bunch of people die in the end. It's farcical. It's great. And at the end of the movie, after all the stuff has gone on, the director of the CIA asks, "So what have we learned from this whole exercise?" And the answer is nothing. We didn't learn a damn thing, I think is the response. And he's like, "Well, let's wrap it up and clear it out." And I think that's the point of these challenges, is like, did we learn something from this whole exercise? Did we learn something about the platform that we need to make? Did we learn something about the software that we're using? Did we learn something about the applications? Did the teams learn about their gaps in their workforce? After all of the activity, did we learn a damn thing from this whole exercise? The answer better be yes.
Welcome back to Beyond the Quantum Headlines. This week, Matt and I are joined by two great guests, and we're talking about something that's moving faster than almost anyone predicted a year ago. Quantum used to be a someday technology. Not anymore. We're seeing real pilots and early production use running right now. And not just in one lane. Finance, pharma, logistics, material science, aerospace, energy. Quantum's showing up as a serious tool across a wide spread of industries. And the smart money's betting the real breakout isn't quantum alone. It's quantum plus AI. But here's the thing about turning a quantum and AI idea into something real. It's really one type of expertise that gets you there. You need someone who actually owns the problem. You need the infrastructure to run the thing at scale. And you need someone independent enough to tell you honestly whether it's working. Problem, infrastructure, research. And fortunately, we have some experts today at the table who will be able to speak about some of these topics. So before we kick off the discussion, let's get to meet them properly. Michael, you're the infrastructure piece representing AWS. Over to you.
Thanks, Chris. Great to be with you. Great to see everybody here today. So my name is Michael Brett. I lead the go-to-market team for quantum technologies at AWS. My job is helping customers of AWS connect with quantum technologies in whatever form they need. Typically that involves providing them access with our Amazon Bracket service, where we make available a range of different quantum computers and simulators and other technologies to help them do their work. So, my team's job is to help customers of AWS access quantum computers and a range of other technologies, and it's a lot of fun doing that.
Yaakov, you're our independent voice in the room, representing MITRE.
Great. Thank you so much, Chris and Michael. Great to have a chance to be with you as well. My name is Yaakov Weinstein. I'm the Chief Scientist for Quantum Technologies at the MITRE Corporation. For those who may not be familiar, MITRE is a not-for-profit government contractor. We service and support various agencies within the federal government, and we have strong indication both from the government and just in general that we want the quantum ecosphere to grow. And so that's really turns out to be MITRE's job. We want to raise the water level. We want to raise all the boats. We want success here in the United States and throughout the world in quantum technologies.
Right. So kicking off our discussion today, the main concept question, from idea to proof of concept. What does it actually take to turn a quantum and AI idea into reality? Who wants to start?
I'm happy to go first if that's helpful. Well, in short, the answer is work. Work hard. But a little bit more realistically, beyond just Einstein's Edison's 1% inspiration, 99% perspiration. This something like a challenge is a great motivator and also a great environment and framework in order to be able to do that work. Everybody is cheering for you. Everybody wants you to succeed. The people at AWS, the people at Airbus, the people at Cleveland Clinic, the people at all those corporations that are supporting this challenge and Quantum Insider, they all want the best projects that are possible. They all want you to succeed. Take advantage of it. There are all sorts of people here that are more than happy to help you out, to work with you, and to make sure that what you are able to come up with and the work that you put in really bears fruit. So this is that in a nutshell. I think that's what you really need.
Yeah, it might be useful to break down like what are the easy things and then what are the hard things. So the easy things, accessing quantum computers is really easy today. There are a variety of different ways that you can do that. Your favorite cloud service provider, can certainly make that available to you. There's a wide range of different quantum computers available now of different capabilities that you can access on demand at relatively low cost and run a workload. So accessing quantum computers relatively easy, especially like compared to what it was even 5 years ago. It's very low barrier to entry to actually access a quantum computer now. The other easy thing is programming a quantum computer. So there are a ton of very high performance software libraries out there, a great open source community, the AI coding assistants, whether you're using Kiro on Amazon or Claude Code or anything else. It's super easy to write a quick program that can access those quantum computers and have it run, and to get the syntax right and get the programming right, and get something out of it. Anyone listening today could probably get started and run a real quantum algorithm on a real quantum computer within about 30 minutes of this podcast to get something. The hard parts are in selecting the right algorithm to program in the first place. So how do you match the problem that you've got to the right kind of algorithm that can run on a quantum computer? That connection is quite difficult to do, and to make good judgment calls about the variety of quantum algorithms that are out there and how to optimize those algorithms to the particular problem that you've got to work with. That is a deep expertise kind of skill. AI tools can kind of help you a little bit with that, but they're not yet at the stage where it can completely replace the human knowledge and human expertise that's required to do that matching. The second thing that's really quite difficult is fitting that algorithm to a specific quantum computer. So quantum computers have got different pros and cons. There's different capabilities on each one. Fitting a algorithm to a specific quantum computer, a target system, it takes a lot of understanding about that specific computer and its capabilities, and then what trade-offs that you're making along the way. So that's like a challenging piece. And then the third thing that's quite difficult is then how do you optimize the overall runtime, the overall workload that you need to run that includes both the quantum, the classical, the hybrid operation between them, the compilation strategy, the analysis of that workload. That requires experience and expertise and knowledge of how do these systems all fit together. So there's some easy stuff, there's some really hard stuff. And the good news is the barriers are coming down all the time, but the hard stuff is still hard. And bringing in experts, bringing in a community to help you out with that will take you a lot further.
Hey, Chris, can I jump in here?
Go ahead.
So just a little bit of background. When I started writing about quantum, let's say 2019, 2020, if I used the word quantum anywhere within 3 or 4 words of AI in a headline, I would get in trouble. So to get around that, I started using hybrid quantum AI, and I still got in trouble. And so, like, my question now is, we're freely and openly talking about quantum AI. Like, what is it? What are we talking about when we're talking about quantum AI?
I think that's a $1 million question, or at least $200,000. I think there are a number of different ways to think about quantum and AI. So first of all, if you're coming from a more, let's say, scientific perspective, there's the capability of quantum computers to perform different algorithms that one would generally categorize as AI or machine learning better on a quantum computer than you could on a conventional computer. So you're trying to accomplish something, you're trying to do image classification, let's say, so you can do that image classification perhaps with less training data or with more accuracy or with greater speed on a quantum computer than on a conventional computer. That's, I think, what, at least in the scientific community, one might call quantum machine learning. But that's not the only aspect of AI or machine learning that I think really comes into play here. Number two, there's the AI for quantum. meaning that you're building a quantum computer, you're designing a quantum computer, you're trying to perform, you're trying to come up with a quantum algorithm. So regular normal AI on your conventional computers can help you do that. And so then you're using AI or machine learning and all of its various forms in order to help enhance quantum computing, and not even necessarily quantum computing. One of the things that we're doing at MITRE in support of our sponsors is to look at digital twins, quantum sensors. So it's not limited in that way to quantum computing. It really does span the entire space of quantum technologies. And then you can have even something else, which people might call quantum inspired. And that is the realization that when one has the ability to think broadly and think in new ways, so it's likely to actually also affect the way you used to think. And so, you might, your ability to kind of like raise the level into a different dimension and start thinking about, hey, how would I implement machine learning on a quantum computer, actually can give insight and ideas into modifying conventional computer techniques. This was demonstrated about around that time, I believe, Matt, in 2019, when Scott Arrington famously asked his student Aaron Tang to look at something related to quantum machine learning, and she realized that in fact quantum was not needed at all. You could do everything conventionally and get a better algorithm out of it, but the thought process that went into that new algorithm was through the realm of quantum mechanics. And so, so I think there are a lot of ways to kind of play back and forth between quantum and AI or machine learning in ways that, as you said, Matt, even 7 years ago, people just really hadn't grasped at that time. Mm.
Yeah, I totally agree with Yaakov on that framing of quantum for AI and AI for quantum. From what we've seen at AWS so far, quantum for AI is really unclear, like, what the potential speed up, the potential application of quantum computing in assisting in machine learning, or eventually AI training and inference and reasoning models. We don't know yet if quantum will play a role, in that function in compute. Hopefully, but there's a heck of a lot of work to be done between to answer that question. We need better computers, we need better experiments, we need better software to explore that. So that is a open question mark. Quantum for AI. AI for quantum is a clear yes. There are a ton of examples already about the role of AI in assisting with coding and design and compilation to help drive quantum computing performance. We have a recent example with AWS with Quantinuum and HighVerge and NVIDIA that looked at a compilation step.
Thanks. That's perfect. I wish I had those explanations 7 years ago, but
if I could just for a moment build off of what Michael said, a lot of the quantum machine learning efforts that are going on are actually simulated on conventional computers. And so people, including from MITRE, this is not a negative thing, this is a positive thing. People are publishing papers about quantum machine learning and saying, hey, look what a quantum computer could do. And then they're doing their simulations on conventional computers, which actually demonstrates what a conventional computer can do. And so, we don't want to go the route of underestimating what conventional computers can do as well, and we want to take advantage of that in order to be able to construct, design, and then program our quantum computers.
So a quick follow-up question that I think fits really nicely into the flow of this discussion. Quantum is still a developing technology, which makes benchmarking quite tricky. What do you think is a good way to go about benchmarking quantum solutions in a field that's kind of moving under your feet? And also, where is the value of the solution at such an early stage?
Yeah, that's a really good question. I think there are a couple of different approaches here. So there's one question that we're very interested in, which is, can you put a number, a, a quantifiable number on, let's say, the power of a quantum computer, right? What says that? And I'm not going to bother going into individual companies. But what says, that quantum computer A is more powerful than quantum computer B, especially if quantum computer A may be, superconducting qubits, and quantum computer B might be, ion traps or whatever it is. So that's very good. That's a very good question. I've in the past talked about a specific metric called quantum volume, which was initially constructed by IBM. I happen to like it because it's one number, it's relatively straightforward to understand, and therefore it's useful in that way. Other places, for example, IonQ uses algorithmic qubits, and other places, other companies use their own metrics. But having metrics is important. If you can have a metric that is agreed to in terms of its language, if I say quantum volume, I can attach a mathematical equation to it, that allows people to actually talk to each other. And that's important too, to have those common definitions, common vocabulary, so that people actually know what they're saying to each other as opposed to talking past each other. And again, even two people who have the best of intentions may end up talking past each other if the vocabulary is not set. And then there's more the question that kind of addresses the challenge, which is an application-based benchmarks. And that's what you would do if you're benchmarking conventional computers, right? You have something like LinPack. You want to know how fast your regular computer does certain matrix multiplications or whatever the case may be. And if only it were that simple, right? If all of our quantum computers could factor numbers, then we would say, okay, my quantum computer is better than your quantum computer because my quantum computer can factor correctly a larger number than your quantum computer. And then everything would kind of be fine. You'd have a very nice way of benchmarking it. But we all know that quantum computers can do a lot more than factoring, and a lot differently than factoring. And so just the ability to factor is not really the best benchmark. And so we end up, the situation I think that we end up in, and again, this is not necessarily a negative situation. It just demonstrates the complexity of where we are in terms of quantum computing, is to say, well, we have these challenges. Let's see what people can do. And in a way, so of course, we're all trying to find solutions. Of course, any of the wonderful teams who are part of this challenge are going to go full throttle and try to come up with the best solution for that for what they're doing. But under that, there's what every team's actually also doing is benchmarking the quantum computer that they're working on and demonstrating what the quantum computer that they end up working on can do. And that's important. That's important as well. Even if it's not necessarily the focus. So back to the explicit question, Chris, that you asked, like how can you benchmark quantum computers when they're constantly moving and constantly changing? Probably the answer is to keep using them and see how well they can do, and then make sure people know about it and can report on what's going on, so that the ecosphere as a whole can get an idea of what's going on.
Yeah, I completely agree with everything Yaakov said there. And just to add, one of the groups that's most active in using and benchmarking quantum computers is the Unitary Foundation's program called METRIQ, METRIQ. At AWS, we are big fans of that program. It's a community-driven. It's open source, which means everyone can have input to it. It's not proprietary to any particular favorable outcome for one particular system. And they do a really great job at a community at regularly testing these computers, each one that comes out, and putting that together as a scored package that anyone can access and understand. So we at AWS, we help support and sponsor that activity running on Bracket. So that METRIQ program, I encourage everyone to go take a look at that. So that's the community kind of view. But then for our customers at AWS, the only metric that really matters is the price performance comparison to the best available classical alternative. That's it. It is an economic outcome for them. So, and the same is true across all of the different computers that we provide. At AWS, we've got CPUs and GPUs and other special purpose processors for training and inference. It doesn't matter what they're comparing to, they're looking for the best price performance outcome compared to the best available alternative. And to date, no quantum computer has delivered a better outcome than the best available alternative at this stage. That day will come. But that's what customers are driving their understanding of. Price performance comparison compared to the best available classical alternative.
So a quick follow-up question I have to that, and by the way, super interesting, both of you, really great insight there. And a deeper layer to this is, going on to where the value is actually derived. So one question that I have, when it comes to challenges, is it more about the most exotic or challenging problem that you can solve? Or is it more about one that has the closest or real commercial value?
Kind of both. And it really depends on, well, let me try to formulate this as follows. One of the wonderful aspects of the challenge is that we have so many different people coming from so many different perspectives, trying to address challenges that are all formulated carefully, right? You go online and you read exactly what the challenge is, but we all know that people are going to read those same exact words differently. And because of that, we're going to get a range of submissions, not just in terms of how well they may perform on a given quantum computer, but even in the way that they're addressing the problem and even the way they're interpreting the problem. And so what we're gonna find is that you'll have some teams that are saying they're gonna say, I'm gonna try to do this like the best, and some teams they're gonna say, I'm gonna come up with this novel way of doing it. And sure, they want it to be the best too, but even if it's not the best, it may be the most novel, and that could be interesting. That could be interesting as well. So, um, I I really think in terms of what we're trying to go for, that's going to be up to the judges, but in terms of success of a challenge like this, right, all the all the solutions are likely going to be useful. Even the ones that may fail to win, if they're well formulated, if they're well constructed, if they're written out well, somebody will read it, and somebody will take advantage of it and say, yeah, this person had good, this team had good insights, and just because you win or don't win a specific challenge doesn't mean that in the long run it's not something useful. So in terms of like the goal, I'm not sure that you need to choose either or. I think, yeah, the judge is going to have to choose one first place winner at the end of the day. But I trust, and given that I have relationships with a lot of a lot of different companies that are represented here, I'm confident that those companies and the people who are representatives of those companies for the challenge are going to read all the entries carefully, and they're gonna try to get what's novel and what's amazing, what's great about each one of them. And just because somebody doesn't win that specific challenge doesn't mean that it's not going to be valued. And who knows, maybe get a callback.
So I love the movie Burn After Reading. It's a Coen Brothers movie from back in the early 2000s. It's funny as hell. Like a bunch of CIA people tripping over each other. There's disaster after disaster. A bunch of people die in the end. It's farcical. It's great. And at the end of the movie, after all the stuff has gone on, the director of the CIA asks, "So what did we learn from this whole exercise?" And the answer is nothing. We didn't learn a damn thing, I think is the response. And he's like, well, let's wrap it up and clear it out. And I think that's the point of these challenges, is like, did we learn something from this whole exercise? Did we learn something about the platform that we need to make? Did we learn something about the software that we're using? Did we learn something about the applications? Did the teams learn about their gaps in their workforce? After all of the activity, did we learn a damn thing from this whole exercise? The answer better be yes. That like we went through this challenge and we learned a bunch of stuff that we can then apply to the next one and the next challenge and the applications that go after that. So that's on my mind whenever we go into one of these challenges. Like, what are we going to learn from this activity?
So Michael, go ahead, Matt.
Oh, sorry, I have a follow up on that because I think these challenges, just covering them, I think have value. I think first of all they're fun, and I think that they increase the brand awareness, to use a marketing term about quantum. It raises the awareness of quantum. But do you think these challenges are important? Have you seen, I know, Michael, you've been part of so many. Have you seen like real benefits from running these that, scientific, business? I'm just curious.
We certainly get a ton of like real driving advanced use of the service. So on Bracket, these challenges kind of push Bracket to new frontiers, pushing the service a little bit harder in an innovative way or in a way that hasn't been done before. And so we get a lot of product feedback out of that. How do we, all the edge cases that make a service like this better and improve it for next time. Absolutely, we get a lot of that. And I know the hardware companies do too. These challenges tend to drive much higher traffic and much higher use in a shorter period of time. So you can get to stress test the system a lot more. So that's good. It also generates a lot of reference kind of case studies for different sectors. So the last time we did this challenge with Airbus and BMW, that just generated a lot of referenceable kind of ideas that we could then put in front of other folks in the manufacturing sector and say, like, here are two leaders, Airbus and BMW, doing great stuff. These are the kinds of problems that they've looked at, and the areas around that. And so that's got a lot of benefit to us in opening up the conversation with other leaders in that sector who are looking for inspiration about what to do. So super useful.
Michael, in the beginning of this discussion, you mentioned about some of the barriers that are coming down in developing quantum solutions. I'm wondering, besides the back-end access to quantum compute, what are some of the resources that need to be made available on the infrastructure side? And also, what makes the AI component in a quantum AI solution more novel?
Yeah, I think one of the big areas for investment for the AWS Bracket team this year is in our integration with high-performance compute. So how do we better orchestrate and schedule and provision the classical compute side of any quantum compute workload? And it's a non-trivial thing. Like, these computers sit in a particular region, they're accessed by particular systems, and we need to help our customers be able to set up and manage and provision and cost control all of the classical compute component alongside that, using the tools that they're used to. So we've got at AWS a whole bunch of high performance compute tooling that can set up clusters and do tightly integrated workloads, loosely integrated workloads, use tools like Slurm for scheduling. That's what our HPC customers are used to. So Bracket needs to fit into that construct. And so a lot of the engineering activity this year is helping to make that easier and easier to run quantum as just another computer within a overall high performance compute workload timeframe. So that's one piece where we're doing a lot of work there. And similarly with AI, so we have a service at AWS called Bedrock, which is the AI service. There's Anthropic and OpenAI and Meta models and AWS's own models sit within like that service. And so if a customer is consuming AI on the Bedrock service, how can they connect that across to Bracket and like call the quantum computer from there and make that as low friction as possible? So I tend at AWS we tend to find like a lot of the engineering effort goes into like these little kind of moments of friction between services. Like, how do we reduce that as much as possible so that the overall parts of AWS kind of like fit together into a higher performing whole. And so that's where a lot of the effort and investment goes into, is identifying these friction points between services and like taking those out of the way so that the overall effort really sings when a customer wants to run a workload.
Okay, so we are approaching the 30-minute mark. This has been a really great discussion, but before we wrap up, I did want to give the both of you a chance to leave people with something to walk away with. Maybe a take-home message for anyone watching who's thinking about getting into quantum and AI. Yaakov, let's start off with you.
I'm a big fan of quantum. I definitely know less about AI, but that seems to be the way that that regular normal computers are going. So therefore, it makes sense that we want to include that. I would say, from my perspective, interacting with the government, there is a lot of what Michael had said earlier. The government specifically is looking for solutions. It doesn't necessarily care what those solutions are. They want the black box, and I'm sure customers want this as well. They want the black box that's going to solve all their problems for the least amount of money, and that's great. That's what everybody should want. The other thing to remember is that especially within the U.S. government, there are all different parts, and the different parts of the U.S. government don't necessarily work together. It's a little bit more Wild West than you might find in perhaps in other countries, and that's great. That's what the United States was built on, and that's the way the United States continues to function. And so, what I would urge our our potential teams for the challenge, and really anyone who's interested in quantum and AI, to think broadly and to realize there's lots of different aspects out there. There are lots of different problems. There are lots of different people who are interested. And just because you might enter a challenge and perhaps not win, or even enter two challenges and not win, like, don't give up. There's a lot. It's a great ecosphere. I'm a total fanboy when it comes to this, maybe because I've been in this game for so long. I started my graduate work in quantum in 1997. But like, I think the ecosphere is wonderful. There are so many wonderful people in the ecosphere. There's so many people who really just want to help each other out. And of course, the different industries are in competition in some way. The different industry partners are in competition in some way. Of course, all the different companies are, but it seems to actually work out for the better. It seems that people really want to see the ecosphere as a whole grow. And so if you're dedicated and you're interested and and you're enthusiastic about it, like, go talk to people, work with people, try to show up to a conference or so if you can, or a workshop if you can, and just let people know that you're around and that you're interested. And I want to wish everyone, obviously the best of luck on this challenge. But just because you may not win this specific challenge, please don't give up. It's a wonderful ecosphere. There's plenty of room for more people as we continue to see quantum to grow. And if you want to be part of it, the door is open. Please just walk in.
Yeah, I was going to say exactly the same. Like, this community is really welcome. I'd recommend to folks, like, the open source community in quantum is really strong. There's a great way to kind of just get started by helping out on the various open source libraries that are out there, to make a contribution of some kind. They're always looking. The projects are always looking for people to help out with that. So you might learn something through this challenge. We're like, oh, I could add that to the library of Penny Lane or Qiskit or Bracket or the NVIDIA CUDA-Q libraries, et cetera, et cetera, et cetera. There's a lot there. So I'd encourage folks that are getting started in quantum here, find friends in quantum that you can work with, and there will be many of them who will welcome you. Collaborate with them, start contributing to the open source world, and you'll feel like you're making an impact through that.
Matt, any take-home message from your side?
My fondest wish is that this challenge is successful and someone comes out with quantum advantage using quantum AI, and I can use those headlines without concern after this. But it was a great chat. It's really nice to listen to your side of things.
Excellent. So what I'm taking away from this chat today is that not enough compute is no longer an excuse. If you've got the idea, the infrastructure is there, the only question left is whether or not you move on that. So Michael, Yaakov, thank you so much for making the time and being so open with us in this chat today. Really appreciate it.
Pleasure. Thank you.
Pleasure.
Thank you.